Hello everyone, my name is Sam van Damme and I'm a PhD researcher at IDLab Ghent University and IMEC, and in this presentation I will show you the content of our paper, a full and no reference metrics accuracy analysis for volumetric media streaming. Now in this slide you see a holographic elephant that was actually used by a German circus to replace real-life animals in their acts. And this is actually quite remarkable, as 40 plus years ago this was still a total science fiction. For the Star Wars fans amongst you, think about the 1977 scene of Star Wars Episode 4 A New Hope, in which Princess Leia is actually delivering a message as a hologram. Now, of course, there are still some differences between both applications, because first of all, the elephant is still a local application, while the Princess Leia hologram is actually sent over a network. Now, the bottleneck here is bandwidth requirements, because current point clouds actually need gigabits per second to be sent over a network for remote access. So we need compression for that. And of course, if you are talking about compression, we also have a need for objective real-time quality of experience monitoring. So we asked ourselves the question whether traditional video metrics are actually up to this task. And we actually performed some previous research on this particular topic, in which we correlated full reference metrics such as VQM, PSNR, and SSIM, which is highlighted in the slide, to subjective mean opinion scores. Now, as you can see from the graph, SSIM is actually showing very strong correlation to mean opinion score, but only on a per video basis, meaning there is a content dependency as the curves are shifted depending on the video at hand. Second, as you can see from the y-axis, we're also working in a very small working range of SSIM of about 0.02, which means that a very small deviation in SSIM actually leads to a very high difference in mean opinion score, which is of course impractical to work with. And it's our assumption that the reason for this is actually the fact that a lot of background is taken into account when calculating the quality metric, such that background removal and region of interest selection could prove a solution to this. Third, I would also like to remark that SSIM is a full reference metric, so although it can be calculated on a frame-by-frame basis, we still require simultaneous access of both the reference and the distorted content to calculate quality, which is of course unwanted if we want to provide real-time client-side quality estimation. This leads us to the following research questions. So first of all, can we find an objective, probably full reference benchmark that correlates well with subjective perception and in addition is content independent, contrary to SSIM? Second, can we improve the working range of traditional video metrics by means of background extraction and selection of regions of interest, which can then be weighted to obtain a quality metric? And third, is it possible to use pixel-based no-reference features to provide a real-time quality assessment model for volumetric media? Now, how did we approach this? We used the volumetric media dataset from our previous study and provided a setup in which the end-user device can actually request the point cloud objects in different quality representations, as is the case for traditional adaptive streaming. And these objects are then embedded within a video that is sent over the network to the client side, where we implemented a background extractor mechanism based on which a set of full and no reference metrics is calculated, which can afterwards be compared to a subjective benchmark in terms of Pearson linear correlation. Now, the full reference metrics that we calculated in our study are SSIM as discussed, and also Netflix VMAF, because of its correlation that tends to be good with subjective scores for traditional video. In terms of non-reference metrics, we calculated blurriness, noise, blockiness, and also spatial information. Now, for the background extractor itself, the background extractor is based on a foreground background mask calculated by means of Bayesian segmentation. And we added a noise removal layer on top of that by means of morphological closing. And for this particular frame, this leads to the following mask. And for each of the objects, we then simply take the smallest enveloping rectangle with an additional threshold on the region of interest size, also for noise removal reasons, which then, if we translate it back to the original frame, leads to the following regions of interest, which we can then use for particular region of interest selection or Gaussian weighting. More in detail, this means that we are taking a linear correlation of a certain quality metric Q over each of the regions of interest, where we determine the weights alpha, beta, and gamma based on a set of assumptions. A first one is the standard baseline, in which no region of interest selection is performed, so we simply take the whole frame to calculate quality upon. In a second one, we average the quality scores for each of the regions. And then in the center approach, we actually assume that the user is watching the region of interest closest to the center of the frame. Alternatively to this, we can also take the other regions of interest into the calculation by weighting them based on a Gaussian weighting function, of which we put the main at the center of the middle region of interest. The new and the new Gaussian approach are actually similar, with that difference that we do not take the middle region of interest, but the region that most recently appeared in the frame, which leads to this Gaussian weighting procedure. Which brings me to the experimental setup. We used the dataset based on the 8Y dataset with 4 point cloud objects in it, which are shown on the slide. And using these, we actually created 3 video sequences with 8 configurations per video, which differ in terms of bandwidth, bandwidth allocation, and viewport prediction. The first video sequence consists of the 4 point cloud objects put it in a line, after which the camera is moving in parallel to this line of objects. And then the second and the third video are actually a semicircle constellation in which we are zooming in and out on a particular figure after moving focus to the next one. And the difference between video 2 and video 3 is simply that the first 2 point cloud objects are used in video 2, while object 3 and 4 are used in video 3. The dataset is also subjectively annotated, both in terms of single and double stimulus, and for each of the experiments 30 subjects participated. And the tests are evaluated on a 2-dimensional screen, where the sequences are shown in random order with inclusion of a hidden reference. Which brings me to the results of our study. So first of all, in terms of benchmarking, we see that VMAF is actually for both the double and the single stimulus approach, providing a working range that is about a factor of 10 wider than is the case for SSIM. In addition, you can also notice that the fitted curve of our VMAF is actually a better fit for the double stimulus approach than is the case for the single stimulus approach, which is of course logically, as double stimulus is closer to full reference assessment. Now, although VMAF is providing to be a good benchmark, it has a temporal component to it in its traditional implementation, which makes it not suitable for online evaluation. SSIM, which can be calculated frame by frame, is more suited to this end. So for that reason, we investigate whether we can increase the working range of SSIM by means of background removal. And the answer to that question is yes, as we can see here on the graphs, where dark green is the standard baseline and each of the other colors is one of the background removal mechanisms we discussed. And we actually see a clear increase in working range of SSIM. For example, for the new Gaussian approach, we go from an interval of 0.97 to 1 to an interval of 0.85 to 1. Now, of course, SSIM is still a full reference metric, so not suited for client-side quality estimation. So for that reason, we actually researched whether we can also use no reference metrics to calculate quality. Here you can see a heat map with Pearson linear correlation for each of the no reference metrics we calculated in correlation to the 3 benchmarks. So the double and single stimulus mean opinion scores, and also VMAF as an objective benchmark for each of the videos and each of the background removal approaches. First of all, we can see that background extraction is actually leveling or even improving the correlation values in most cases, with blurriness and spatial information as its most important exceptions. Second, we also see stronger correlations to the mean opinion scores than to VMAF, which is a good thing, as we are actually trying to model subjective perception by means of no reference metrics. But still, if we look at the tendency of VMAF, we see that this is similar to the mean opinion scores, meaning that we can use VMAF as an objective benchmark, for example, for machine learning purposes without human intervention. And then the third remark is that we can also notice strong and stable Pearson linear correlations for both blur ratio and the noise metric over all cases, which makes them two very suitable candidates for the creation of a no reference quality model. Which brings me to the conclusions of this presentation. So first of all, we noticed that we can use VMAF as an objective, content-independent benchmark for offline purposes. Second, we also proved that we can improve the working ranges of traditional video metrics by means of region of interest selection and background removal. And third, we also see that an accurate real-time no-reference model is within reach, where machine learning can, of course, provide a solution, for example, by combining the noise metric and the blur ratio. This brings me to the end of this presentation. I thank you for your attention. And of course, if there are any further questions, don't hesitate to ask them either in the Q&A or by means of email. Thank you very much.